All right, taking a look at page 2 of this practice test. We want to know the net force in the car if the normal force has half the value of the weight. And please note, we're saying that downward is the positive direction and upward is the negative direction. And this is important for when we set up our balanced and unbalanced force equation. So I'll just make a little note here. Now, we want to know the net force on the car if the normal force has half the value of the weight. Let's go ahead and do that by setting up a free body diagram. So we have the normal force pointing up, and we have the weight force pointing down, and let's be careful with our math. Fg, the weight force, is going to be m times g, and the normal force is going to be 1/2 of that weight. Let's be careful. When we actually calculate mg, that's going to give us mg is 800 times 10. That's the 10 right there. And so we're going to get 8,000 newtons. This is Fg. Now, the normal force is going to be 1/2 of 8,000. And that's going to be 4,000 newtons. So the idea here is the net force is the sum of all the forces acting on the object, taking into account the sign. So that's going to be Fg minus Fn. That will be 8,000 minus 4,000. And that gives us 4,000 newtons worth of force. Now we want to use this net force to get the speed of the car. So that's F net equals m times AC. So 4,000 equals 800 times AC. I'll divide both sides by 800 to start with. And when we actually cancel those terms out, we'll get AC is 50, but that's not what we asked for. It's getting us to what we asked for. What we wanted to get was the speed of the car. So 50 is going to be v squared divided by the radius. So 50 equals v squared divided by our radius of 10 meters. And let me make absolutely sure I have that right. So, yeah. And so when we go ahead and get v is going to end up being, so actually the correct answer, when I do it, it ends up being, in fact, 7.07. Let me just back up a second. Here's the deal on this problem. 4,000 divided by 800 isn't 50. It's actually 5. So let me just go ahead and correct that here. This is 5 here. 5. 5. And then we end up actually getting that v squared is 50 when we correct. And that's how we end up getting 7.07 meters per second. Sorry about that. Now, the maximum speed the car can go before losing contact with the ground. So let's be clear, when we're losing contact with the ground, that implies that our normal force is 0. That's what happens when we reach this maximum speed. So we're going to take our equation again, Fg minus Fn. Now we have an unknown acceleration and speed. I'm just going to do one more substitution here. Fg minus Fn, in fact, equals m v squared divided by r. And it's this v that we want to solve for. So we have mg minus 0, that's Fn equals 0, equals m times v squared divided by our radius. Now let's plug in numbers. So we have 800 times 10 equals 800 times v squared divided by our radius of 10. So one small thing, the 800s can be divided out on both sides. And I multiply both sides by 10, so I get 100 is v squared. So when I isolate, v ends up being 10 meters per second. So that's page 2 of the exam.